Okay, we're going to prove a trig identity. A lot of people don't like these things because, well, they kind of force you to think about fractions and all of the principles of arithmetic. And in the context of trig, and that's pretty hard for lots of us. But anyways, let's just get started. This this first thing here, it goes sine, cos, cosine. If you go, it's a trig identity. So look on your sheet, and there's a sine alpha, cos alpha minus cos alpha, sine alpha. And it's a thing, you just look at the identity. There it is. Doesn't that look exactly like that? Well, that's going to give you your first answer. If you've got the sine and the cos, and then the cos and the sine of two angles, all you do is subtract those angles, and that's your answer. So that all of this is just going to turn into sine 5x minus 3x, and that's it. Minus 1. Now we're trying to get the left-hand side and prove that it equals this thing on the right-hand side. Now tangent is sine over cosine, so you'd get a mark for just writing sine 2x over cos 2x. But what's 5x minus 3x? Oh, it's 2x. And then here's this fraction thing. When you have a fraction on the bottom of a fraction, you have to know that you tip and times. You invert and multiply. In Canada, that's what we do. And then the sine 2x and sine 2x will cancel, and you'll just have cos 2x minus 1. Now, I would like to have the cos of a double angle. There's 3 to choose from. Choose the one that's got 1 minus 2 sine squared x. Why is that such a good one? One thing, you're going to end up with your answer minus 2 sine squared x. The other thing is 1 minus 1 is going to equal 0. And oh, that's the right-hand side. That's perfect. It's really nice to get these ones to cancel. Then you get a simplified answer there. Well, there's that whole first identity, 5.4.1 done. Now they ask some questions about it. They say, determine the values of x for which the identity will be undefined between 0 and 60 degrees. Well, first off, we've got a simple way of looking at this thing here. Oh, we're not going to use it. It's going to be undefined. Oh, whenever the denominator is equal to 0. So here's one of the places that it's going to be, is when the tan of 2x equals 0. And when does that happen? You can go shift tan of 0. It happens at 0 degrees. So 0 degrees is one of your answers. I got that mark. When I did this question, I forgot about the other thing. With tangent, there's something else that's undefined, and it's when the tangent of 90 degrees is undefined. So at 0 degrees is one of the answer, but tangent is also defined when when x is 90 degrees. It's undefined. So what does that mean? Then the tangent of 2x equals 90 degrees will be undefined. So that means that 2x equals 90 degrees plus k times 180. So x equals 45 degrees. So at 90 degrees and every 180 degrees, it'll be undefined. But 45 degrees will give you another answer where it's undefined. 2 times 45, because the tangent of 90 is undefined. Hey, I forgot all about it. And it's kind of a fundamental thing with tangent, a graph, is that at 90 degrees, these are asymptotes. It gets closer and closer, but it never equals 90 degrees. You can't, because it's undefined there. Okay, there's that question done.